So moving to example number 2 here. Here we need to show that the factorial of 20 subtract the factorial of 19 plus this factorial of 18 is equal to 362 times the factorial of 18. So now what we're going to do is we're going to look at just the left-hand side here. This one looks a little bit more complicated, so we can always try and make this one more simple, look more like this, rather than try and go simple to hard. So it's kind of going back to, remember when we were proving the trigonometric functions, always start with the more complicated and then try and make it more simple. So what we're going to do is we're going to take each of these factorials and we're going to rewrite them. And we're going to rewrite them in such a way that they're not broken down into all of their multiples, but we're just going to break it down so that way they're some number multiplied by another factorial. And I'm going to go back up top here. Just to help, I want to explain this, and then this way we don't have to write it down a million times. But if we were to say, look at the factorial of 10 here, if I were to say take 9 times 8 times 7 times 6 all the way up to 1, this is 9 factorial times 10. Then 10 times 9 factorial becomes 10 factorial. So there's only the distinction from 9 factorial to 10 factorial is the fact that there's a multiplication of 10 there. So that is the only difference of 9 factorial to 10 factorial. So we're going to use this to help solve, I guess, our left-hand side of the equation there. So using what I just told you there, let's rewrite 20 factorial. And we're going to rewrite it as we see there's 18 factorial here. So what I'm going to do is I'm going to see if I can pull out a like term of 18 factorial and see if everything left over will equal 362. We're just going to try it out, see what happens. So 20 factorial is equal to 20 times 19 times 18 factorial. So remember that difference here is that there's a multiple of 19 and 20. So, you know, break it down, 20, 19, then the rest of it is 18 factorial. So now we're going to go along the same lines with 19. So we have subtract 19 times 18 factorial. Then we're going to leave 18 factorial as it is. That one is nice. It's already in that form, so we don't have to do anything with that. And then what we're going to do is we're going to pull out a like term of 18 factorial. So think of this as, say, a variable. This is x here, x, and x. We're going to pull that out, and we're going to see what is left over. So let's pull out a common factor of 18 factorial. So that means that we are left with 20 times 19. Subtract 19 plus, when we pull out 18 factorial, it doesn't become 0. It's 18 factorial divided by 18 factorial, so any number divided by itself is 1. So just remember, this is not 0. We still have a number there, okay? All right. So then let's simplify our brackets there. So we have 18 factorial. And then we have 20 times 19, which is 380. And if we want to combine this as well, we have negative 19 plus 1 is negative 18. Simplify here in our brackets there. So we have 18 factorial, times that by, and 380 subtract 18 is 362. And we know that with multiplication we can flip things around, so we can actually rewrite this to 362 times 18 factorial. So 20 factorial subtract 19 factorial plus 18 factorial is in fact equal to 362 times 18 factorial. So here we kind of partially broke down each of those factorials so that way we could rewrite them as 18 factorial times some number. And we did that for each one, and then we pulled out that like term, okay? So example number 3 here. Here we need to solve for n. And so this is np2 is equal to 110. So if you're wondering where on earth should we start here, whenever you don't know where to start, you start off with what you know. You know that n, p at 2 is equal to, or we can even start with the beginning, r. That is n. Divide that by n minus r factorial. Each of these are factorials. So let's fill in what we know. We know that this left-hand side here is actually equal to 110. We don't know n, so we'll leave that as n factorial. divide that by, and here we have n minus r, which is 2. So n minus r, which is 2, factorial. Now, it might be a little bit confusing. Now, I think what most people would want to do is they see this fraction, they want to get rid of that denominator, but we're not going to do that just yet. We're going to use the rules that we had in number 2. We're going to apply that to this example here. So what I'm going to do is we're going to have 110. And how can I rewrite n factorial? So if you remember, it is the number times, and it would be the number less, 1 less, so it'd be n times n minus 1 times n minus 2, and then we can leave that as a factorial. So what I'm going to do is I'm going to rewrite it so it looks exactly like this denominator, and then we can cancel out some common terms. So remember, if we can, n factorial is equal to n times n minus 1 times n minus 2 times n minus 3, and so on. So this here, this portion of our n factorial, this would be n minus 2 factorial. So what we'll be left with is n times n minus 1 times that factorial there. Okay? So then that'll be divided there by n minus 2 factorial. Then we can start canceling out some like terms. And what we have left there is we have 110 is equal to n times n minus 1. Now if you guys want to, we can move everything to one side, we can factor, or if you guys are pretty solid on this, you guys can try a guess and check. If you guys can think of 2 consecutive numbers that would multiply to 110, that is absolutely fine, just make sure you check it. But if not, what we can do is we can rate this as, I guess rewrite this to look like factoring, so we'll move that 110 over. So here we have, and I'm going to distribute these brackets, so we have n squared minus n, moving 110 over, that'll be subtract 110. From there, let's look at the factoring. So here we have a product of negative 110 and a sum of negative 1. So what 2 numbers would give you a sum of negative 1 and a product of negative 110? So if you guys can think about that one there. So that one we have negative 11 and positive 10. So we're going to rewrite this middle term here. So we have 0 is equal to n squared minus 11n plus 10n minus 110. We can pull out our common factors in each of those 2 groups. So in our first one there, we have a common factor of n. We have n minus 11 left over. Here we're going to pull out a common factor of 10, and we have n minus 11 like once again. That's how we know we did our factoring right, is if those 2 brackets are the same. Then we can write, pull out our common factor of n minus 11, so we have n minus 11 times n plus 10. Finally, we can solve for each of those variables, so we have n is equal to 11 and n is equal to negative 10. Now, quick question, can we use both of these solutions? So I want you guys to think about the restrictions. What is so special about those restrictions? So one thing to note is that, remember, n cannot be a negative number. It has to be usually 0 or greater, or even a better case for the natural numbers would be 1 and up. So we cannot have n is equal to negative 10. So our only possibility is that we have n is equal to 11. And what we can do to make sure that this is actually, we did the right steps, we got the right numbers, we can check this by substituting 11 in for n. So there we have, it would be 11 p2 is equal to 11 factorial divided by 11 minus 2, so you 9 factorial. If you guys put that into your calculators, you can do it either separately or all together. And what you guys should find is that this does actually equal 110. So get that practice. You know, even put in 11 factorial, then put in 9 factorial, divide the 2 numbers, you should find that you get 110. So it doesn't matter how you go about solving it, as long as you get these numbers in there right, we should find that 11 factorial divided by 9 factorial is in fact 110, which is exactly what we wanted. So let's move on to permutations with repeating objects. So for permutations with repeating objects, a set of n objects with A of one kind that are identical, B of a second kind that are identical, and C of a third kind that are identical, and so on and so on. This can be arranged in, and here we're going to have another little form, different form of our permutation. So we have n factorial, that's divided by A factorial, B factorial, C factorial, and so on. So looking at, with repeating objects, let's look at the number of, objects. So how many times does that object repeat? So there's A times in our first, object. Then there's B of a second kind of object. Then there's C of a third kind, and so on. So you're going to take that factorial of n and divide it by each time it repeats as a factorial. So let's look at an example here. So here we have how many different 10-letter arrangements can you make using the letters of basketball. So here we notice that we have some repeats, or repeating objects, or repeating letters. So if you notice there that there's 2 B's, there's 2 L's, and there's 2 A's, and the rest are just 1's. So to solve this, we're going to write out, first of all, you want to know what a total is. So how many letters are in basketball? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a total of 10 letters, and the total there is equal to n. That is your n value. Then you have to look at what kind of repeating values do we have. So first of all, what you could even do is write out the letters. We have B's, we have A's, S, K, E, T, and we also have L there. So don't do the repeats, just write out the letters, and we can put little values beside them about how many times do they repeat. So ask yourself, how many times does B repeat? So there, as we notice, we have 2. And I'm going to cross them out so I can make sure that I actually did get everything. Then the next one there is we have A and A, so that means that there's 2 A's. Here we have 1 S. There is 1 K. There is 1 E, 1 T, and 2 L's. And if you guys want to double check, even though you guys maybe cross them out, the sum of these letters should be 10. So add this up. We have 2, 4, 6, 8, and 10. So we did make sure we included all the numbers there. So now what we're going to do is we're going to write our factorial, and I'm going to give you a little hint here. Do we need to include S, K, E, and T? According to our little statement above, we do, but what do you know about 1 factorial? 1 factorial is equal to 1. So any number multiplied with 1 is just 1. So we really don't need to write it. So what we're going to do is we're only going to look at the permutations for B, A, and L. So we're going to rehab this equation here. So our total there is n. So we have 10 factorial. Divide that by A factorial. So in this case, our first one there was 2. So 2 factorial. A had 2 factorial once again, and L had 2 factorial. Now you guys can put this into your calculator, or if we want to kind of see the math, what we would have is it'd be 10 factorial. That one there is equal to 3,628,800, or 3,628,800, and that is divided by, so 2 factorial is 2 times 1, so it'd be 2 times 2 times 2. You can throw all that into your calculator, or if you want your denominator there is equal to 8. So it'd be 3,628,800 divided by 8. And what we should get is that we have 453,600 different ways that we can arrange basketball. Alright, so let's head on over to video number 3.